Hello, and welcome to another episode of Mechanics in Sports. Today's sport will be gymnastics, and the topics covered will be moments. As you can see here, this person is demonstrating what was called an L-sit. Now, to look at the L-sit and its moments, first let's draw a diagram with a pivot point. We must assume first that G is equal to 9.81 and that the mass of the person, but not their whole body, only their legs, is equal to 20 kilograms. Also, that the length of their legs is 1 meter, because as we know, for moments we must multiply the weight times the distance. We will also be assuming that the center of mass of the person is halfway along the legs at 0.5 meters. As you can see from this diagram, we must write force downwards equal to 0.5 times 20g, where g is 9.81, calculates that to be 98.1. Hence, as force downwards equals to force upwards, we can say that the total force upwards is at the pivot point equal to 98.1 newtons. Now we can see another demonstration of what is called a cross on the rings. Now, for this person to do this, we must assume that their mass is 70 kilograms. Again, we will say that G is equal to 9.81, and therefore we will calculate the force on the rings, which is upwards, also assuming that the length of the arms are 0.5. To simplify the model, we can do this, where we have two upward forces, distances of 0.5 between the center of mass, which is 70 kilograms. We can calculate it by doing 70 times 9.81, which 9.81 is just G, which gives us 686.7 newtons. And as FD, which is force downwards, equals FU, and we have double the FU, which is the force upwards, we can say that the force upwards will be 686.7 divided by 2. This is another demonstration. However, the gymnast is holding it at 45-degree angle, his arms, which adds an extra level of difficulty to the cross on the rings, as now you have to take into account the degree of the angle. It's a very similar process, as you only have to change the distance between the pivot points and the mass, because as you know, for moments you always take the horizontal distance. Now, we're still assuming that the length of the arms is 0.5 and G is 9.81. The person's mass is still 70 kilograms. Therefore, when we simplify the model, we can see that to work out the horizontal distance, we must use a form called SOHCAHTOA, where we look at the sides of the triangle which we are using, such as the adjacent and the hypotenuse, to find little d, which shows us that we must use cos. So writing 0.5 cos 45 would give us the length of d, the new d, the horizontal distance between the mass of the person and the pivot point. So 0.5 times cos 45 gives us root 2 over 4. But as we have double the distance, it just equals root 2 over 2, which is very similar to cos 45. Now we say that 70 times g, and g once again is 9.81, times the distance gives us 686.7, which equals 485.57. Thus, as we have 2 pivot points, the force upwards is double that of the force downwards, so that gives us the answer divided by 2, which means the force upwards would equal 242.8. Thank you for watching. See you again sometime.